Hello. Let's begin our class. I have updated the course website, and you can find your quiz results. If you have issues about the quiz results, please contact me as soon as possible. And I also updated the accuracy of assignment 1. And you can take a look. Some students got accuracy 0. This is due to your program does not meet the requirements. And I repeated this many times. You need to read the instructions of assignment 1, and your program outputs must meet the requirements of this assignment. And you should take a look of the code template, and you cannot skip any cout statements. You cannot skip this line, or you cannot delete the space after the column. You cannot output additional line breaks. The due date of assignment 1 is next week, and I will post assignment 2 next week. And this week we will learn the flow control. And in the previous week we have learned Boolean expressions. And these expressions will be used in the branching mechanisms and in the for loops. And so Boolean expression is the foundation of this flow of control statements. We have learned the if-else statements, and if we want to make a decision, and we will use the if-else statements, and inside the parenthesis is a Boolean decision. If this decision is true, then the yes statement will be executed. Otherwise, if the Boolean expression is false, then the no statement will be executed. We talk about this pitfall, and when you want to perform equality comparison inside a parenthesis, if you made a typo, you perform assignment inside the parenthesis, then the program outputs may not be what you expect. the else part can be omitted. You can only use the if statements. And for this example, if you do not insert braces, then the if statement will only contain single line. So for this example, you can try to compute the value of wager. Here I will demonstrate this example. For this example, suppose we want to compare my score with your score. Then you use the if statement to make the decision. And for this example, do you know what is the value of wager after these statements? The value of wager is 50 or 150. If you think the value of wager is 150, please raise your hand. Oh, okay, if you think the value of wager is 50, please raise your hand. Sorry, 50. If you think the value of wager is 50. Oh no, and let's see the result. The result should be 150. And if you want to, because this line does not inside the if statements. If you want to include multiple statements inside the yes statement, then you need to add a pair of braces. So sorry, I changed this. I changed this to 20. So now I change the values of my score and your score, and you will see that you will see that this statement is not executed because the Boolean expression is false. So the yes statement is not executed. So the value of wager is 50. But if you remove the braces and you run the code again, you notice that wager is 150. This is because the if statement only contain the single line. So and the indentation means the leading spaces, and the leading spaces will not affect the program. So in fact, the indentation is only for the readability and will not affect the results of the program. So don't be affected by the indentation. So whether you whether you add the indentation will not affect the program outputs. The next slide talks about nested if-else statements. When you want to make a decision inside another decision, then you need to you can use the nested if-else statements. For example, you use the if statement to determine whether speed is greater than 55. Then you can make another decision inside the if statement. You can determine whether the speed is greater than 80 or not. The next slide introduces multi-way if-else statement. Previously, our decision is binary. You only have one condition. When you have multiple conditions, like this example, we have multiple conditions. Temperature is less than -10, and temperature is less than or equal to 0. When we have multiple conditions, then we can use multi-way if-else statements. And this is similar to if-else statement. Between if and else, we add else if part. So if you have more conditions, you can add these conditions in the else if part. And these conditions will be checked in order. In order means we check conditions from top to bottom until the first true Boolean expression is encountered. So if this Boolean expression is true, then the if-else statement is finished. If this condition is true, then the if statement will be executed, and then the if-else statement is finished. However, if the first condition is not satisfied, then the program will check the second condition. And if this condition is still not satisfied, then the program go to the next condition until the Boolean expression is found, the returns true. And finally, if no condition is satisfied, then we will go to the else part. So here you can try to practice this example by yourself. to practice this example, you need to declare variables. So now I declare variables, and I give these variables some initial value. And now suppose the initial value of temperature is -12, and here Sunday is a constant. You can give this constant any value. And we see that the first condition is satisfied because temperature is less than -10, and the day is equal to Sunday. So this condition is satisfied. And then the if statement is executed. So the program prints stay home. And this is the if else statement is finished. And let's try to modify the conditions. Suppose we so here I add another constant Friday, and I change the day to Friday. And you will see this equality comparison is not satisfied. So the first Boolean expression generates false, and the program will go to the second condition. So and this condition is satisfied. So the program will output stay home but co-work. And you can also try to modify the condition. For example, here I modify to -8. If I modify the initial value of temperature to -8, we see the second condition is not satisfied. So the program go to the next condition. And this condition is satisfied because -8 is less than or equal to 0. So the program will print dress warm. You can also try to modify this initial value to, for example, to 5. And if the temperature is 5, then all the 3 conditions are not satisfied. And then we will go to the else part. So the program prints work hard and play hard. Let's see the next statement. This statement can be also used for multi-way decision. This is the switch statement, and this statement requires some keywords. The first keyword is switch. The second keyword is case, and you also need the break keyword. And default is also the keyword. So we have 4 keywords in red colors. Follow after the switch, we also have parentheses. And inside the parentheses is a controlling expression. So what is a controlling expression? A controlling expression means it can be a Boolean value or a enumeration constant or integer types or a character. But the controlling expression cannot be a floating point. cannot be a string. So here, actually, you can think controlling expression as you can regard controlling expressions as integer values because Boolean variable can be treated as an integer, and enumeration constant is also an integer, and the character can also be used as an integer. So you can regard controlling expressions as an integer. So inside the switch statement, we have many cases. So here I show two cases, and you can include many cases. And after the case, is followed by some constant. This constant can be integer, character, or enumeration constant. And after the constant, you need to add a column. This is to separate the constant from the statement. And after the column, you can add many statements under this case. And when you want to terminate this case, then you need to use the break statement. And when the program see the break statement, then the switch is terminated. And if you do not add the break statement, the program will continue to the next case. So here, the break statement is required if you want to stop the program execution after this case. And if no case conditions are satisfied, then the program will go to the default part, and execute the default statements. So the next slide shows one example. Here, vehicle class is an integer. If this integer is 1, then the program will go to case 1 and executed the statements under case 1. And if vehicle class is integer 2, then the program will go to case 2 and executed the statements under case 2. If the vehicle class is not 1 or 2, then the program will go to the default part and execute it, and will print unknown vehicle results. So here is one typical example about how to use the switch statement. Next, we will have a quiz. And if you need answer paper, please raise your hand. Anyone need answer paper? Here is the first question. Here are 3 statements, and you need to determine the value of VAR3 after the 3 statements. 30 seconds left. Then I turn on the second question. The second question is to execute these statements. You need to determine the value of y after these statements. You cannot use tablets or laptops during the quiz. So you cannot use the tablet. Yeah, I know, but you cannot use the tablet. The same as laptop cannot be used. Only after the quiz you can start to use laptop and tablet. Uh, 30 seconds left. Then I will turn on the third question. This question has one variable bonus, and the initial value of bonus is 10. You need to determine after these statements what is the value of bonus after these statements. For this question, you need to answer according to literal wording. And this means do not try to fix this question or try to add any assumption by yourself. 30 seconds left. Then I will turn off all the questions. If you use answer paper, please write down your student ID and name and submit the answer paper to me. And let's see the answers. For the first question, the answer is option 2. Option 2. So we need to compute the value of VR3, and we need to compute. To do this, we need to evaluate VAR1 divided by VAR2. So you need to determine whether this is integer division or floating point division. And clearly, both VAR1 and VAR2 are integers. So this is integer division. So 13 divided by 3 is 4.25, and you discarded the results after decimal point. So here, the result of integer division is 4, and 4 times 3 is 12. And here you might be confused. Here is a floating point, but actually this floating point will be converted to integer because the data type is integer. So here 3.0 will be converted to 3, and the 3 is assigned to VAR2. So to determine this division, you need to find out what the data type of VAR1. You need to find out the data types of the numerator and the denominator. For this question, the answer is also option 2. Here we need to determine the value of this Boolean variable. And we need to decide whether this equality comparison holds. And we need to compute x modulo 2. And because x is an odd number, so x modulo 2 is 1. So this equality comparison is false. So the value of this Boolean expression is false, and the false is assigned to this condition variable. So here we have inside the parentheses is false. Therefore, we go to the else part. So y will be added by 1. So 3 plus 1 is 4. So the answer to this question is option 2. For the last question, the answer is option 3. But most people choose option 4. Let's see this question. Here, the initial value of bonus is 10, and we need to perform some comparison. And here, the value of day is 11, so the first condition is not satisfied. Then we will go to the second condition. And we know that this condition is not equality comparison. This condition is assignment. And this is legal in C++. You can refer to the previous slides. In this slide, we talk about the difference between equality operator and assignment operator. So inside the parentheses, it is legal to use assignment. So I say, do not try to fix this question or try to aid assumptions by yourself. You just answer this question according to the literal wording. So here, after this assignment, the value of day is 24. And we know inside the parentheses, you can treat integer as Boolean value. The Boolean value is true, because if the integer is not 0, then the Boolean value will be true. So here is true. And therefore, the else if statement will be executed. So bonus is added by 20. So 10 plus 20 is 30. So therefore, the answer to this question is 30. Any questions about the quiz? If no questions, then we will return to our slides. So here I will use one example to demonstrate how to use the switch statement. You can the indentation does not matter, but the indentation can help us to understand the code. So you can click beautify. This function will automatically perform indentation. And for this example, we need to declare variables. And we also need to declare two variables. Total, you need to and after the switch statement, we can print the value of total. So here, after the switch statement, I will print the value of total. So let's try to run this program. So here, the initial value of vehicle class is 1. So the program will go to case 1 and print passenger car, and the value of toll is set to 0.5. And the break statement will terminate the switch. After the switch is terminated, then we will go to this line, and this line will print the value of toll. So toll is 0.5. So we see that since vehicle class is 1, and so case 1 is executed, and the value of toll is 0.5. And you can modify the value of vehicle class. Now you go to case 2, and the case 2 will print bus and set the value of toll to 1.5. And if vehicle class is 3, then we will go to the default class, and the default class will print unknown vehicle. And you see that because we do not modify toll under this default case, so the value of toll is 0, and the 0 is its initial value, because we didn't modify this variable under the default case. And you can try to modify this example. For example, here for example, I set vehicle class to 1, and you try to remove the break statement, and you can observe what will happen if you remove this break statement. So if you try to remove this break statement, you will notice we go to case 1. So case 1 will print passenger car and set the value of toll. However, the switch statement does not terminate because you remove the break statement. So we will continue to the next case, and the next case will print bus, and the value of toll is set to 1.5, and finally break. So if you also remove this break statement, we will continue to the default. So if you remove all the break statements, then all the cases will be executed. So The program prints passenger car, prints bus, prints unknown vehicle. So here the break statement is required if you want to separate each case. You need to add the break statement. And so if you forget to insert the break statement, this will not cause syntax error, because this is legal. It is legal to omit the break statement. Sometimes we deliberately to omit the break statement. For this example, sometimes we want to share statements between different cases. For example, we have uppercase A and lowercase a. If you want the two cases to share the same statement, then you will omit the break statement after the uppercase A. I think time is up, so let's take a break for 10 minutes.
喂，注意一下，我们那个服务课本送到了，然后我现在要给家庭的人。蔡依萍在吗？好，那郭威婷在吗？好，好，这给你。10号在吗？全英班10号。26号在吗？26。OK。
Hello. Let's continue our class. we talk about the switch statement, and we know the break statement is optional. You can choose whether to use the break statement or not. And if you omit this statement, then if you omit this statement, then after case 1, the switch statement continues to case 2. And sometimes we do this deliberately. For example, we want to share statements between different cases. And one of the common mistakes about using switch is to forget to include the break statement, and this will not cause syntax error. So sometimes it is difficult to find. You need to remember the syntax of the switch statement. One of the biggest use of switch statement is to use it like menus. Switch can provide you a big picture view of your program. Menu is like when you use a software, we usually have many options. For example, if you click the file, if you click on file, you will see a menu pops out, and under this menu include many options, and each option is a case. So each option is a case under the switch statement. And if you click this option, then this is equivalent to executed the statement under the selected case. And we have finished the introduction to switch. Next, I will introduce another operator, another conditional operator. This operator is called a ternary operator. This operator is different from the operators we learned. Ternary means the input. This operator has 3 inputs. Previously, operators are either binary or unary. So here this is the first time we encounter a ternary operator. So this operator has 2 symbols. Here is the question symbol and the column. So, and the inputs, the 2 symbols forms the ternary operator. So, and this operator has 3 inputs. The first input is on the left-hand side of this question mark. So the first input is a Boolean expression, and the second input is between the 2 symbols. The third input is after the column symbol. So this operator has 3 inputs. And actually, this operator is a shorthand notation for the if-else operator. If you want to perform if-else statement like this, suppose you want to assign some value to the max variable, depending on whether n1 is greater than n2. So this is a very common if-else statements. And if you want to use a shorthand notation, you can choose to use the ternary operator. If n1 is greater than n2, then this is a Boolean expression. So this will generate true. And if this value is true, then this operator will return the second input. So N1 will be assigned to max if the Boolean expression is true. However, if the Boolean expression is false, then this operator will return the third input. So N2 will be assigned to max if the Boolean expression is false. And this is equivalent to the if-else statements. So this is just a shorthand notation. Actually, this will lower the readability of your program. So if you want to perform multiple statements, I suggest to use the if-else statements, because if-else statements is more is more readable than the shorthand notation. You can here you can omit the parentheses because this ternary operator has lower precedence. So greater the comparison has higher precedence than the ternary operator. So you can omit these parentheses. And you can do some experiments to about how to use this ternary operator. Here is one short example. Suppose we have a Boolean variable flag. If you say it to true, then this operator will return the second input. So max will be set to 1. And if you set flag to be false, then this operator will return the second input. So 2 is assigned to max. Of course, you can use if-else statements. So you can also use the if-else statements to achieve the same results. Here I need to declare this variable. So here here flex is false. So the program will go to the else part, and the max is set to 2. Actually, about the variable name, we should not use max, because max is used by other libraries. So it is better to choose another name. Because when I forget to declare this variable, you see the error message is I try to overload some functions. This means this is a function defined in some library. So I think we should choose another name. For example, max. And you see that the the error message is different. It says this variable is not declared in its scope. And next, we will go to the next part. The next part is about loops. When you want to repeat some actions, you will use loops. Or you want to access some, or you want to deal with an array, you will use the loops. And in C++ or in C language, we have three types of loops. The while loop. While loop is very flexible. And the second one is the do while. Do while is not as flexible as while. And actually, you can always replace the do while with the while loop. So actually, I seldom use do while because I need to remember the syntax of the do while loop. So actually, I often use the while loop to replace the do while loop. The third one is the for loop. This for loop is commonly used for accessing elements in an array, and we will use this for loop when we learn the arrays. Here is the syntax for the while statement. A while is a keyword and followed by parentheses. And inside the parentheses is a Boolean expression. And after the parentheses is a body statement. This body statement can be a single statement or a compound statement. For compound statement, you need to add a pair of braces to include multiple statements. And you can also choose to include nothing. You can include the null statement. Include nothing is also legal. So you can just add a semicolon after the parentheses. The left-hand figure is the flow chart for this while loop. First, the Boolean expression is evaluated. This is like the if-else statement. And if this expression generates false, then the while loop terminates. And if this Boolean expression is true, then the body statement will be executed. And after this statement is executed, then the flow control returns to the Boolean expression. This Boolean expression will be evaluated again. And if this value is true, then the while loop continues until the Boolean expression becomes false. We will use one simple example to demonstrate how to use the while loop. So the statement inside the inside the loop is called a loop body, and each repetition of a loop body is called an iteration. So if you execute the loop body, we often call we perform an iteration. And now suppose we declare a variable count. So we declare a variable, integer variable count, and we need to set some initial value. Suppose its initial value is 0. And here we add a while loop. This while loop is to increase the value of count. So in each iteration, the value of count will be added by 1. And also in each iteration, the program prints high, prints this string. And after a while, we can print the value of count. So for this example, do you know the loop body executes how many times for this example? So we need to trace the statements. So when count is 1, this Boolean expression is true because 0 is smaller than 3. So the Boolean expression generates true, and we will enter the loop body. So the program will print high, and you can also print the value of count inside this. So here we also print the value of count inside the loop body. And the second statement is to increase the value of count. Then after the first iteration, we know that the value of count becomes 1. And then we need to evaluate the Boolean expression again. So here count is 1, and 1 is less than 3. So the loop body will be executed again. The value is increased by 1, and the count becomes 2. Then we go to the Boolean expression again, and the 2 is less than 3. And then we execute the loop body, and the count becomes 3. And when count becomes 3, then this Boolean expression generates false, and the while loop terminates. So when this while loop terminates, the value of count is 3. So we see that if you run the program, the while loop will execute 3 times. The first iteration prints high 0. The second iteration prints high 1. The third iteration prints high 2. And when count becomes 3, this Boolean expression generates false, and the while loop terminates. And this line will print the value of count, and the count is 3. The next slide introduces the do while statement. Here we have one additional keyword do, and after the do is the loop body. So here is the loop body, and we know that this loop body will be executed at least once, regardless of the Boolean expression. So this loop body will be executed at least once. After this loop body is executed, then we evaluate the Boolean expression. If the Boolean expression is true, then we execute the loop body again, and this loop body will modify the value of count until the Boolean expression becomes false. So you can also try to execute these statements. So here, if I set count is 3, so here I set count is 3. And we see that this loop body is executed once, even though this Boolean expression is false, because the control flow will execute the body statement first. So this body statement at least run once, and because count is 3, and this Boolean expression generates false, so the do while terminates after the first iteration. And after the do while statement, the value of count is 4, because this line is increase the value of count by 1. And if you set the initial value of count to 2, then the loop body will be executed twice. Oh, sorry. 2, 3. Also, if the initial value is 2, then this execute. I said let's multiply it to 1. And we can always replace the do while statement with the while statement. You just copy the loop statement. For this one, you just copy the body statement before the while keyword. Then you can achieve similar results to do while. The next slide introduces the comma operator. We already use this operator. We use this operator to separate multiple expressions. For example, when you want to declare multiple variables, when you want to declare multiple variables in the same line, we use the comma operator to separate the declarations. So comma is an operator. And for this example, we have a parenthesis, and inside the parenthesis we have 2 assignments. And the 2 assignments are separated by the comma operator. The first assignment assigns 2 to the variable first, and the second assignment assigns first plus 1 to second variable. And the common operator, the comma operator will return a value. And this value is the value is the last expression. So the comma will return first plus 1. So for this example, first is 2. And first plus 1 is 2 plus 1 is 3. So 3 is assigned to second. And this comma operator will generate a value 3. And the 3 will be assigned to result. So if you run this line, the value of result is 3. And actually, we do not recommend you use comma like this example, because this example combines multiple assignments inside one in one line, and this will hurt the readability of your program. So we recommend you do not write your program like this. It is better to separate each assignment in one line. So for this line, it is better so for this line, it actually performs 3 assignments. It combines 3 assignments in one line. But actually, this hurts the readability of your code. It is difficult to understand. So it is better to rewrite this statement as 3 assignments like this one. So it is clear that you understand the sequence of the statements. So we always recommend readability has a higher priority than brevity. Next, I will introduce the for statement. We will use the for statement repeatedly when we deal with arrays. And below is the syntax of the for statement. After the for is a keyword. After the keyword is a parenthesis. And inside the parentheses, we have three parts. The 3 parts are separated by the semicolon. So we see there are 2 semicolons inside the parentheses. And the first part is initial action. The second part is Boolean expression. The third part is update action. And let's take a look of the flow chart. So when a program runs this for loop, first initial action is executed. So and actually initial action can be empty. So here initial action is optional. And after initial action is executed, then we will evaluate the Boolean expression. If the Boolean expression is false, then the for loop terminates. On the other hand, if the Boolean expression is true, then we will go to the body statement. The program will execute the body statement. And after the body statement is executed, then the program will execute update action. And after update action, we will re-evaluate the Boolean expression again. And if the Boolean expression is true, then the for loop will continue to execute body statement and the update action until the Boolean expression becomes false. When the Boolean expression becomes false, the for loop terminates. So in this slide gives you a typical example about how to use the for loop. Suppose we want to compute the sum from 1 to up to 10. Then you can write a for loop to compute the value of this sum. Then here you need to declare two variables. The first variable is to the first variable is the sum of these integers, and the second variable is an index. This index, the value of this index will be updated by the for loop. So we see that in the initial action, we set the initial value of n to 1. And the Boolean expression is n is less than or equal to 10. Because we want to generate integers up to 10. And the update action update the value of n by 1. And the body statement is to increase the sum. So here the body statement is sum plus n. We assign sum plus n to sum. So we can run this program. You see that after this for loop, sum is 55, and actually you can change it 10 to any number. For example, to 5. Because 1 plus 2 plus 3 plus 4 plus 5 is 15. One common error is to forget to initialize the value of sum. If you forget to perform initialization, you see that we obtain a random number. Because if you in C++, if you do not properly initialize a variable, its value is unknown. So here, if you do not initialize sum, its value is some random number in the memory. So here, it is important to initialize the value of sum. Here, we don't initialize n because we will initialize n in the for loop. Here is one minor. Here you can choose to declare n inside the for loop. I will show how you can do this. So here we declare variable n outside the for loop. And actually, you can choose to declare n inside the for loop. So here you can also declare n in the initial action part in the for loop. So this is legal in C++. However, if you do this, but you cannot access n outside the for loop. So now suppose you want to print the value of n. And this will cause syntax error. Because outside the for loop, we cannot access n. So you will see some error message here. So we see the error message is n was not declared in this scope. So if you declare n inside the for loop, you can access n inside the for loop. And outside the for loop, we cannot access this variable. So if you want to access n outside the for loop, you need to declare n before the for loop. So here, so you so here I declare n before the for loop, and the scope of n. Later we will talk about scope of a variable. So the scope of this variable n is the entire main function. So we can access n outside the for loop. And actually, you can choose to initialize n in this line. You can choose to initialize n when you declare this variable, and you can the initial action is allowed to be empty. But actually, we prefer to initialize n in the initial action because it is easier to understand. Because you keep all the operations related to n in one line, so it is easy to understand the initial value of n and how n is updated in one line. So we usually prefer this style. So you clearly know n begins from 1 and ends at 5, and each step is 1. So we usually use this style to when you want to use an index. And actually, you can do some more practice. For example, you can try to suppose you want to generate a sequence 1, 3, 5, 7 up to 11. Then here you need to adjust this for loop to generate this sequence. So here you need to modify this Boolean expression. You need to modify this number to 11. Also, you need to adjust the step. The step is 2, so here you need to modify the update action. Update action, you need to modify this to n plus equal to 2 because the step is 2. And here we can we can print the value in each of n in each iteration. Sorry. So we see that if we run this code, in each iteration we print the value of n, and after the for loop, we obtain the sum of this sequence. And after this loop, the value of n is 13. Because here we perform in each state, the value of n is increased by 2. So, and 11 plus 2 is 13. So after this for loop, the value of n is 13. And you can also try to generate other sequence. For example, suppose you want to omit 5 and 7. Suppose you want to omit the two numbers, then how can you do? So here you can add some if statements. You can use if statements to perform decision. So now suppose I want to exclude 5 and 7. I only want to generate 1, 3, 9, 11, 13. Then here you can add if statement. And this statement will determine whether n is less than or equal to 3 or n is greater than or equal to 9. And we notice that you see that the for loop only prints n is 1, n is 3, and n is 9, n is 11. So actually you can combine for loop and with if statements, you can generate any sequence you want. Here is a comparison with the for loop. We have an equivalent example using the while loop. And to do this, you need to initialize n when you declare this variable. And the Boolean expression is the same as the left-hand side. And inside the loop body, you need to put this plus n also in the body loop body. So you see that you can also use the while loop to replace the for loop. But actually, we prefer the for loop because for loop is clear. You understand the initial value and the end value of n in one line. However, for the for loop, you need to trace the value of n because the value of n will be updated in different lines. So So when you need when you need a counter, we usually use the for loop. The next slide is about when we want to repeat n times, and you have two choices. You can begin the counter from 1, or you can begin the counter from 0. If you choose to begin the count from 1, then the Boolean expression is count is less than or equal to 3. So you will run this for loop 3 times. The first way is more intuitive because we usually begins from 1. The second way is to, if you want to run the for loop 3 times, and you can begin with count from 0, and you need to modify the Boolean expression. Here is less than. Count is less than 3, so count is 0, count is 1, count is 2. So this for loop also runs 3 times. Actually, in C++ or C, we usually use the second one because the index always begins from 0. Later, when we learn array, we need to access array elements, and the index always begins from 0. So we should familiar with the second usage. So when you see this usage, you should know this for loop will run 3 times. I think time is up, so let's take a break for 10 minutes. Hello, let's begin our class. We already learned how to use the for loop to repeat some actions. And the next slide is about some common mistakes about for loops. For example, you add a semicolon right after the parenthesis. And let's see what will happen. First, let's run the normal version. So here is the here is the normal version, and this for loop will print hello 10 times. And you can also print the value of count. So we see that the for loop print this string 10 times. However, if you add a semicolon after this parenthesis, and this is legal, you can run the program again. So this is legal. You can add a semicolon right after the parenthesis. The compiler has no warnings, but you see that the hello only print once instead of 10 times. And this is because if you add a semicolon right after the parenthesis, this means the loop body is empty. So here we have no loop body. So actually this for loop only declares a variable and update this variable until the value is 10. And then this for loop terminates. So this for loop will not print any string. And after this for loop, this CL is outside the for loop. So we will see this hello only print once. And you cannot access count here. We already explained. Because you declare count inside the for loop, so its scope is only within the for loop. You cannot access count outside this for loop. If you try to compile the code, we get the error message because count was not declared outside the for loop. And if you remove the semicolon, then this line is inside the loop body, so you can the code can be compiled. The next statement is about the next example is about a while loop. I will show how to use this while loop. This while loop will read user inputs and will save the user input in response. And the value of response will determine whether the loop will continue. So here I declare response, declare this variable, and its initial value is set to 1. So this Boolean expression will generate true. So we will enter this while loop. Oh, I need to. I need to. So I want to demonstrate the normal version first. So here I remove the semicolon. This is the normal version. I will demonstrate this first. So you see that we enter the while loop, and in the first iteration, CR will output a string or enter value. Then cin will read some user inputs. So now suppose we enter 2, and you press enter. Then because and the 2 will be assigned to response, and this Boolean expression is evaluated again. And because 2 is not 0, so the loop will continue. So the program prints enter value again. Then here cin will read user input, so we can choose to enter another value until you enter 0. When you enter 0, response becomes 0, and this Boolean expression becomes false. And the while loop terminates. So this is the normal usage of this example. We want to use the for loop, or we want to use the while loop to repeatedly read some user inputs until the user input 0. If the user input 0, this for loop, this while loop terminates. This is the normal version. However, if you add a semicolon after this, after the parenthesis, if you add this semicolon after the parenthesis, actually the syntax is legal. It is legal to add a semicolon right after the parenthesis. So your program can be compiled, and here now we run the program. However, you see nothing. You see nothing in the console, and this is because here we stuck in this line forever, because the loop body is empty. So you have no chance to update the value of response. The value of response is always 1, and therefore we create an infinite loop in this line. So your program will stuck at line 6, and this is because we have no way to modify response. The response is always 1. If you want to terminate your program, you can type Ctrl+C. This will send an interrupt signal to your program. The operating system will stops your program, and you will see the exit code is 2, not 0, and this means the program finishes abnormally. Here, because we use Ctrl+C to stop this program. So here, if you for the second example, if you add a semicolon after the parenthesis, you will create an infinite loop. Sometimes we need an infinite loop. In some real applications, if you want to periodically run some tasks, then you can use an infinite loop. And to create an infinite loop, you can use the syntax. You can use while 1, because 1 is true, and the Boolean expression is always true. So this while loop will run forever. And in some applications, infinite loops are desirable for embedded systems or for games. When you want to periodically run some tasks, you can use infinite loops. The next slide introduce two statements related to the for loop. The first one is the break statement, and we already see this keyword. We already see this keyword in the switch. In the switch statement, we already see this keyword. This keyword is to break the switch statement. When the program is executes this statement, the switch is terminated. And for the for loop, the break statement is similar. This break statement will terminate the for loop immediately. Below is one example about how to use the break statement. Now suppose we create a for loop, and this for loop is very simple. We run this for loop 10 times. We create an index iter begins from 1 and increase by 1 and up to 10. So this for loop will create a sequence 1, 2, 3 up to 10. And you can run this. And you can run this program. So the for loop will print hello 1, hello 2 up to hello 10. And after the for loop, I print the value of iter. So after the for loop, the value of iter is 11. Now you can try to experiment how to use the break statement. So now we add an if statement. If iter is equal to 3, and we add the break statement here, then you can guess what will happen to this for loop if we add this if statement. So you can guess the value if we add this statement. What is the value of iter outside the for loop? Because this break statement will terminate this for loop, so after hello 3 is printed. Sorry. The program will only print hello 1 and hello 2. Because when iter is 3, we will not print hello 3 because break is before cout. So the program will not print hello 3. So the program only prints hello 1 and hello 2. So you see that if you add the break statement, if you add the if statement with break, you will see the program output like this. And after the for loop, the value of iter is 3. because when iter is 3, we perform break. So after the for loop, break is 3. Another related statement is continue. Continue is different from break because continue only ends one iteration, and if there exists the next iteration, the loop will continue. So continue only ends one iteration, while break completely ends the loop. So we can try to modify this example. So if you replace break to continue, you will notice the program will print hello 4, hello 5, up to hello 10. So we observe that only hello 3 is skipped because when iter is 3, the statements after continue will be skipped. So when iter is 3, the statements after continue is skipped. So you will not see hello 3. And however, the for loop will continue. So iter will be increased by 1. So iter becomes 4. And we go to the next iteration. Iter is 4. And 4 is not equal to 3. So we will go to the cout statement. So here we'll print hello 4. And this loop will continue until iter is 11. When iter is 11, this for loop terminates. And you see that when the for loop terminates, the value of iter is 11. In this way, you can try to practice how to use the break statement and the continue statements. In fact, you can choose not to use continue. You have another way to express the same action. So I will show how to do this. Now suppose you want to skip the third iteration. You have another option. You can use here is another option. I add another if statement, but I do not use continue or break. Here I change the Boolean expression to iter not equal to 3, and you will observe the same outputs. So when iter is not equal to 3, the cout statement will be executed. So this is similar to the above. So you can choose to not to use continue. I will demonstrate another case for break. So you can also rewrite this program without using break. You can think how to modify this program. Suppose we don't want to use break. We always use if. Then what will you do? How to decide the Boolean expression? So if you want to achieve the same result as the break statement, here you can add if statement like this. So you see, if I modify the condition to iter is less than or equal to 2, and the cout will only be executed for the first and the second iteration. So you can achieve the same results as with the break statements. But this is slightly different because if you use this, the for loop will run 10 times. However, if you use break, the for loop only runs 3 times. So there is still some difference. Next, I will talk about nested loops. The for loop allows you to create a sequence. A sequence is one-dimensional. When you want to create a two-dimensional sequence, you need to use a nested for loops. So like an array is two-dimensional. You need to determine the row number and the column number. So if you want to create an array, you need to use nested for loops. Here is one example. Now suppose our goal is to print an array like this, a two-dimensional array. You want to print 11, 12, 19 up to 91, 92, 99. You want to print a two-dimensional array. And to do this, you need to use a nested for loop. So you see, we have 2 indexes. The first index is for the first dimension, and the second index is for the second dimension. So you need to create 2 index variables. Here I create a nested for loop, and I just print the index variables. So when I equals 1, the inner for loop will be executed from J from 1 up to 9. So here you will print 1 1, 1 2, 1 9, and then I is increased by 1, and I is equal to 2. Then we enter the inner for loop again. When I is 2, the inner for loop will increase J from 1 up to 9. So in the second iteration, the program will print 2 1, 2 2 up to 9. And you can run this program. So you see the program output. And suppose you will feel that now suppose you want index J to be in the same line. If you want to do this, you can remove this line break. You can choose this line break to be a space. Then in this way, if you replace the line break with a space, then all the result will in the same line. So we now see that all the outputs are in the same line, but you also want to add a line break after when I is increased by 1. So suppose you want to add a line break when J is increased by 1, and here you need to here we output a line break. But because we have two statements, here is the first statement. Here the for loop is the first statement, the first compound statement, and the CL is the second statement. So here we need to include a pair of braces. So after we print the first line, we output a line break. So here you can see the program outputs. I properly ate the space and the line break. Now you can do something more. So for example, you want to demonstrate 1 times 1, 1 times 2. You want to compute the multiplication. So here you can also add the multiplication result. So here is the multiplication result. 1 times 1 is the multiplication table. You can produce this table, use the nested array. Actually, you can perform other experiments. Here I made a smaller table. You can control the steps. So for example, the steps is increased by 2. Then we see that if you modify the step to be 2, then here we have 1 1, 1 3, and 1 5. And you can also reverse the sequence. For example, you want to begin from 5 and end with 1. Suppose you want to reverse the sequence, then you can begin with 5. And here you modify this to. So here I show you can also reverse this sequence. So here we begins from 5. I begins from 5. This is the first iteration, and in each iteration, I is decreased by 1. So in the second iteration, I is decreased by 1 until I is greater than or equal to 1. So you can try to use the nested for loop to create any two-dimensional array. Here we have another question about a two-dimensional array. How do you apply break statement to a two-dimensional array? Now suppose I use a break here. Suppose I add. So here I modify this example to our previous example. Here I add a break statement here. If I is equal to 3, then break statement is executed. So let's see what will happen for this program. You can try to guess what is the program outputs. Will this break statement terminates the entire for loop, or just terminates the inner for loop? We have two options. The first one is the break will only terminate the inner for loop. The second option is the break will terminate the entire nested for loops. So do you know which one is correct? If you think this break will only terminate the inner for loop, please raise your hand. If you think this break only terminates the inner for loop. Okay. If you think this break will terminate the entire nested for loop, please raise your hand. Okay. I will show you the answer. The answer is this break will only terminate one for loop. So if you add this statement will only terminate the inner for loop. We can run this program. We see that when I is 3, the CR will not be executed. So we will not see 3.1, 3.3, 3.5. This line will not be printed. However, after this break, the entire loop does not terminate. When I is 3, this line is skipped, but the update action will be performed. So I is increased to 4. When I is 4, then the inner for loop will be executed, and this if statement is skipped because I is 4. When I is 4, then the cout statement will print 4.1, 4.3, 4.5. So if you use the break statement inside the nested for loop, the break statement will only break one for loop. You can also change the position. Suppose if you change the position to outside the for loop, so actually, if I move this if statement outside the inner for loop, then this break will stop, will terminate the outer for loop. So you see the program output is this. So here is the comment about the break or continue statements. So any break statement only applies to the innermost loop statement containing that break. So this is the rule when you want to use break inside a nested for loop. I think sometimes it is clear. In this case, you can choose not to use break. For example, you can use use if statements. You can modify the Boolean expression. If I is smaller than 3, you can achieve the same results. So here I modify this equation. You see, the program achieve the same results. And sometimes this is more readable. This is more readable because this just becomes if I is less than 3, then the for loop is executed. But if you use break, you need to think about the breaks which for loop. So you can you have many options how to express your ideas with these statements. We have finished the introduction of the for loops, and the final part is about file input. We already use cin to read user inputs, and you need to manually enter some values. And sometimes we want to read values from a file on your disk. And sometimes this is more convenient because you can automatically perform some tests to your programs. So suppose you want to read some input from a file on your disk. You can create an object like cin. And to do this, you need to use the data type if. This means input file string. You need this data type is defined in the IO string library. And you use this data type to declare a variable. This variable behaves like cin. And you can use this variable to read inputs from a file. And next, we need to associate this variable with file name on your disk. So suppose you put file name .txt. You have this text file and your source code in the same folder. Then you can use this file name. And if your text file is in another folder, you need to input the folder's name in this file path. And after you use this open function to associate the input string with the file name, then you can start to read. You can start to use this variable to read inputs from the text file. So this input string is like cin. Cin will read one integer or one string and save the string to some variable. So here I declare another variable text. So after reading one word from this text file, then the string this word will be stored in the text variable, and you can choose to print this variable. And this while loop will continue to read all the words in this text file until the end of this text file. When we reach the end of this text file, this variable will return one symbol denoted as EOF, end of file, and the EOF is 0, so this while loop will terminate. And finally, we need to close this input string. This will release this file so that others can access this text file after your program. So you can choose to read inputs from a text file. You can also save outputs to a text file. For example, you can we use cout to output some strings on the screen, and you can also choose to save this program outputs in some file, and you can do it the same way. You can see the contents, table of contents of our textbook. We have a chapter, streams, and file input output in chapter 12. And this chapter will teaches you how to read and write from files. And here we only provide a quick introduction, and we will not go into the details. And we have finished this chapter, flow of control. And next we will go to the next chapter, arrays. So first I will introduce what is an array. And after introduction to array, we will learn function basics, or what is a function, how to define a function, how to use a function. And after function basics, we will continue to the next part. We will combine array with functions. You will send array to some functions. So an array in C++ is a container. This container will collect many data of the same data type. For example, you want to collect many integers, or you want to collect many floating points, then you will create an array. One restriction is that the data type of the elements needs to be the same. This is the restriction of the usage of array in C++. If you need to create a container containing elements with different data types, you need to use another container defined in other libraries. Here my introduction is to build in the built-in arrays in C++. Now suppose we want to create 5 integer variables. You can use score 0, score 1, up to score 4. You can create 5 integer variables in this way. But this is very tedious, especially when the number of variables is large. If you want to create 100 integer variables, you need to manually copy and paste. This is very tedious. So when we want to create many variables, we usually use arrays. The syntax is like this. You use the data type and followed by a variable name. This is the name of the array name. Then you add a bracket after the array name. And inside the bracket is the array size. So in this way, you can declare an array with 5 elements. And we will associate each element with corresponding index, and the index is from 0. So if you declare an array with 6 elements, the index is from 0, 1 up to 5. This is 5 is size -1. And if you only declare this array, its initial value are unknown. So I use question mark because we haven't initialized this array. And when you want to access its element, you can use the index. For example, you want to modify the value at the index 3, then you can use this syntax. You use the array name bracket, and inside the bracket is the index. So here 3 is the index. Then you assign 10 to the element at the index 3. So I think the lesson has come to an end. So we can dismiss.